Example 2. Example 2, graphing the quadratic function. So here the function is a little bit different. What we have is 2x squared minus 8. Now, this is missing that middle term. It's usually ax squared plus bx plus c. Ax squared plus bx plus c. This one has an ax squared and it has a c. It's missing that middle term. But we still have to find a way to graph this. Hopefully we can find a way to graph this using intercepts, which is the section that we're in. So the first thing I want to do is, just like it says here, what we want to do is want to change the look of the function. So let's go ahead and do that. What do I mean by change the look? Let's go ahead and factor out anything that we can factor. It looks like both of these terms have a 2, so let's go ahead and factor out that 2. And once we factor out that 2, we end up with 2 times the quantity x squared minus 4. The question is, where do we go from here, right? Well, if you notice inside of the parentheses, x squared minus 4, that's a difference of 2 perfect squares, meaning that we can factor that. So if we can factor that, then what we have is that we need 2 perfect squares. So let's separate it into 2 quantities. So it'll be 2 times the quantity x plus 2, 2 times the quantity x minus 2. Right, another way to think about that, the square root of x squared is x, so we have x times x. The square root of 4 is 2, so we put 2 on one of the quantities, 2 on the other quantity, and we have that the only difference is one is positive and one is negative. Now we've set it up so we can actually find the zeros of this function. Now it's in that general form of the equation that we got at the beginning of the chapter. What we learned from this one, from this form, is that a is equal to 2, p is equal to negative 2, and q is equal to a positive 2. Now mind you, again, these numbers are prior to these numbers, prior to substitution. Once you substituted the number into the general form, the sign changes. Okay? So keep that in mind as we go forward. Now, also what this tells us is that the zeros are P and Q. Right? P and Q. So our zeros are at negative 2, 0. And the other 0 is at 2, 0. So we have the 2 coordinate pair. That's where it crosses the x-axis. This parabola, where it's all said and done, it's going to cross that x-axis in 2 different places. So now we'll go ahead and we'll plot those. Put a point at negative 2, 0. We'll put a point at 2, 0. Also, what we noticed is that a is equal to 2. A is greater than 0. That tells us that this parabola is going to be opening upwards. Okay? It's going to be opening upwards. Now, let's go ahead and find the axis of symmetry. Now, recall back from that concept that we learned at the beginning. We can find the axis of symmetry by finding the average of P and Q. So we'll go ahead and say x is equal to P plus Q over 2. Do a little bit of substitution and then a little bit of math. We find that x is equal to 0. That means that our axis of symmetry is at x equals 0, which is in fact that y-intercept. Let's go ahead and graph that, just so that's what it'll look like once we graph that line there. So we know that the vertex now is going to be on the y-axis. So let's go ahead and find that vertex. So we know what x equals. We know that x is equal to 0. We'll do our substitution and see what we get for the y-coordinate of that vertex. Okay? So let's see, what we end up with is f of 0 is equal to 2 times 0 squared minus 8. A little bit of math. We have that f of 0 is negative 8, and that negative 8 is the y-coordinate of the vertex. So then we can go ahead and we can actually plot that. Plot the point 0, negative 8. So we have a better idea, a visual idea of what our graph is going to look like when we're done. Okay, so now we have 3 points. The 2 x-axis, the 2 x-intercepts, and we have the vertex. Now all we have to do is just draw a smooth curve, as smooth as you can now, curve through those points. Now yours might be look a little bit different. It might be in fact look a little bit better than the one I drew up here. Something to keep in mind is that these are parabolas. They're in the shape of U's, not in the shape of V's. They are in the shape of U's. Okay? So keep that in mind as you go through these examples. Okay? Now let's talk about the domain and the range. The domain of this function, we'll think about it, this is a quadratic. The domain is all the same. So that means that the domain for this one is exactly the same as the previous one, all real numbers. The only thing that changes is the range. Now let's talk about the range. Let's think about that. How do we find the range? We have to use the y-coordinate of the vertex. Okay? We do have to use the y-coordinate of the vertex. The y-coordinate of the vertex is -8. The parabola is opening upwards because a is positive. That means that y has to be greater than or equal to a -8.